So I want to find an equation in standard form for an ellipse with a center at the origin and passing through the points 5, 3 and -4, 3.759. And they don't mention these points being vertices, so I'm just going to have to assume that they're not. Centering at the origin is nice because that tells me now that h and k are 0. So the equation I'm looking for is x squared plus y squared. Oops, I need my a squared over there and my b squared over here is equal to 1. So we have two unknowns here, my a and my b, but I have 2 points to make an equation to solve. So that's going to give me, for the first point, x is 5. So 5 squared over a squared plus 3 squared over b squared is equal to 1. So there's one of my equations for a and b. And then the other one, with the other point, would be -4 squared over a squared plus 3.795 squared over b squared is equal to 1. So 2 equations, 2 unknowns. We should be able to solve this. So let's say we're going to solve the first one for a squared. So I would subtract the 3 squared over b squared to the other side. So I'm just going to write that as 25 over a squared is equal to 1 minus 9 over b squared. And I'd like the a to be in the top. And so instead of having a complex fraction, let's see, I think I'll rewrite this right here. We can write the 1 as b squared over b squared minus 9 over b squared, which gives me a common denominator of b squared. So I have b squared minus 9 over b squared. And I want to flip both sides. So right now I have 25 over a squared equals that. So then a squared over 25 equals b squared over b squared minus 9 squared. Then we can just multiply that 25 up to the other side. And we've solved here for a squared. And then we can bring that over to the other equation and try and solve. So replacing the a squared with all of this, we're going to get a complex fraction that we'll have to clean up. So -4 squared is 16 divided by, and that's the main fraction bar there, make that bold. Then we have 25 b squared over b squared minus, let's see, that's not a 9 squared, it is just a 9, excuse that. B squared minus 9. And 3.795, I might as well square that since I squared the other numbers. So 3.795 squared is 14.402025. Divided by b squared is equal to 1. All right, so we have a fraction within a fraction. To clean that up, we'll multiply by the reciprocal of this bottom one. So that's going to give me 16 times 25, oops, nope, reciprocal times b squared minus 9 over 25 b squared plus 14.402025 over b squared equals 1. And I think what I'd like to do next is to get the b squared out of the bottom, we'll multiply both sides by b squared. So this side times b squared, this side times b squared, and we're just going to reverse the order. So I'm going to get b squared equals And then when we multiply the b squared through, they cancel the b squareds in the bottom. So this b squared distributes to cancel those two. So we get 16 over 25 times b squared minus 9 plus that 14.402025. And we clean up that side right there. Now we still have a b squared here. We need to get over to the other side. So we're going to have to distribute. So b squared equals 16 over 25 times b squared minus 16 over 25 times 9. So we'll just say 16 times 9 over 25. We still have that 14-ish number on the other side hanging out. Now we can subtract this 16/25 b to the other side. And if you consider that's a 1, 1 minus 16 over 25 gives us what, 9 over 25? So that sounds right. So again, subtracting this 16 over 25 to the other side with the b squared. Double check. 1 minus 16 over 25 is 25 minus 16 over 25. 25 minus 16, that's 9/25. So these two subtracted give me 9/25 b squared equals this stuff here, negative 16 times 9 over 25 plus the 14.40. Excuse me. That got messy. 14.402025. And I suppose we can clean up all of that, and then we'll divide by the 9/25 and take the square root. So a little more calculator. So from our 14 here, let's move for this, please. We want to subtract. So 14.402025 minus our, what was that again? 16 times 9 over 25. That gives me 8.64025. 8.64025. No, 642.025. And then next, instead of dividing by 9/25, we could multiply by the reciprocal. So b squared equals 25/9 times that 8.64025. And that's going to give me b once I take the square root. And let's name that. I guess I can retype it. So we have 25 over 9 times our 8.64025. Did I type that right? 642.025, and that's coming out kind of nice. And then we want to take the square root of that whole thing. So let's see, will Desmos let me sneak a square root in front? No, it will not. So let's name that thing. Let's see, I'm going to call you C for now. And then I want the square root of C. So I get that crazy number right there. So about 4.8995. And did they tell me any rounding information here? No rounding information, no rounding information. So since let's see, that was given to 3 decimal places, maybe I could round that to 3 decimal places in the end. So that number right there is my B. Now we have a formula, oops, wrong screen, I want that screen. We have a formula for A here, right? We found A was 25 times B squared over B squared minus 9. And then we just take the square root of that and we have A. So once we have that right there, so our B is the square root of that, or B is actually, B squared is that number right there, I can just plug that in here. So we know that A squared is equal to 25B squared over B squared minus 9. And we can just substitute that in for our B squared. And then take the square root. And since we have those numbers saved in our calculator, we don't have to worry about rounding. All right, so that is the number. The B squared is my number C right here. So then applying my formula, I get, let's see, I'm going to have to take the square root of that in the end. Let's call it D for now before we take the square root. And it is 25 times my B squared, which I called C there, divided by 9, or is it B squared minus 9? Let's double check. There's my whiteboard, there you are. Over B squared minus 9. And again, that's the number I'm calling C there. So over B squared, which is C in my calculator, minus 9. And so that number right there, we want the square root of that. So that is what we would call A here, which is the square root of that fraction, D. So I get about 6.324-ish. And supposedly those 2 points are on that ellipse. So I'm going to graph that ellipse to check to make sure I got the right one. Let's write this down. So we get that A is about 6.324. And we get that B is about 4.8995. So if we went to 3 decimal places, that's 4.900. So B is about 4.9. Add that to the notes. So we think that our A is about 6.324, and our B is about 4.9-ish. And let's see if the point's 5.3. Now, since we're rounding, it won't be exactly 5.3, but it ought to be close. So I'm going to graph the ellipse x squared over and 6.324 squared plus y squared over about 4.9 squared should equal, oops, 1. And we should have the point about 5.3 on there. And that looks about right. Let's zoom in. So if I plot the point, 5.3, it should look like it sits pretty close to on the ellipse. And the other point we had was what? -4, 3.795. Let's see if we got that one. -4, 3.759. And yeah, that looks like it's on there too. Well, that was a heck of a lot of work. So we do have a standard equation for the ellipse. So it would be approximately x squared over 6.324 squared plus y squared over 4.9 squared equals 1.